Okay, so here you can see the answers indicated, so that's there for you to cross-reference and check, and we'll do a couple of these, not all of them, just to make sure that you've got the procedure nailed. The thing about formal charges, it's just a formula. You have to remember it, it has to be knowledge. Formal charge is equal to V minus a half B plus L. Okay, what does that mean? Formal charge is equal to the valence electrons in the unbonded atom. So when you find the atom in the periodic table, how many valence electrons does it have? Minus the electrons assigned in the Lewis structure. Okay, so your valence electrons minus the electrons assigned in the Lewis structure. The electrons that are assigned in the Lewis structure can be calculated using this half a B plus L. So what this is trying to say is that half of the electrons in each bond belong to the atom that we're focusing on. The other half belong to the other atom. And the lone electrons belong to that atom. So if they're lone electrons, they're mine, I own them. If I've got bonded electrons, if I'm sharing some electrons, then technically I have ownership of half of the electrons that are in that bond. So we could work this through. If we take as an example, okay, so this one here. So we're looking at A, and I'm going to say, let's check the formal charge of the oxygen on the left-hand side. So we're going to look at the formal charge for this one. So it is equal to V minus a half B plus L. Write that out every time. Any question on formal charge, write that out. Helps you to keep focused on what you're actually doing. So V for valence, 6. Oxygen's in group 6, 6 valence electrons. Minus a half of B, okay? Half of B, 2. There are 2 bonds, i.e. 4 electrons. Half of 4 is 2. Now you could think of this one of 2 ways, and please don't let me confuse you even further if you've got this nailed already. What you are saying by half a B is half of the bonding electrons. I find it easier to actually say B bonds. So instead of half of the bonded electrons, B for bonds. So 6 is the valence electrons minus 2, there's 2 bonds, plus 4, 4 lone electrons, 1, 2, 3, 4. So it's either half a B, half the bonding electrons, 1, 2, 3, 4, half of that is 2, or you can have your B bonds representing the number of bonds, 2. Either way it works, but don't get overly confused by mixing and matching the 2 terms. Okay, if we add that together, 6 minus 2 plus 4, I'm sure you can do that without a calculator, is equal to 0. Okay, so the formal charge there is going to be 0. Let's do another one. So we've got B, we're going to look at the nitrogen that is central. So we're going to look at this one here. V5, nitrogen's in group 5, 5 valence electrons. Half of B, okay, this nitrogen has got 1, 2, 3, 4 bonds. 4 bonds. If it's got 4 bonds, it's got 2, 4, 6, 8 electrons. Half of 8 is 4. Whichever way you think about it, it works. Plus 0, lone pairs. Have a look, there's no lone pairs there. So plus 0. So 5 minus 4 plus 0 gives us plus 1. Okay, so this is just an indication where we get the different pieces of information from. And let's try one more. C, we're going to do the nitrogen on the right hand side, so that's this one. V valence is 5, it's in group 5, minus a half of B. This nitrogen has got 1 bond. It's got 2 electrons, half of 2 electrons, 1. 1 plus 6, 6 lone electrons, 1, 2, 3, 4, 5, 6. 5 minus 1 plus 6 is a minus 2. Key things, don't think that L stands for number of lone pairs. I may have indicated, and we'll use the terminology lone pairs, but what we're actually saying is the total number of lone electrons that we have got in the structure. Okay, so the lone electrons, not the lone pairs. Just be careful on those. So try and have a look, see if you can get some of the others to now match. This question, formal charge can be used electron bookkeeping, but electronegativity values are ignored when we're looking at formal charges. So as we said, we make some assumptions in chemistry. Not all of them are true, very many of them are almost true, but it leads to slight discrepancies between pieces of data. So based on the assignment of formal charge of the atoms in part 1, deduce the Lewis structure that is the preferred one. Now there's one mark here for saying A and B. Both of them are preferred, because they have smallest difference between the two. Now, don't get confused here. It's actually about the difference. A and B have the smallest difference. So A plus 1 to minus 1. The difference between that and the difference between that is the same. The positioning doesn't matter. The difference is the same. So from minus 1 to plus 1 is 2. Whereas this one, we've got plus 1 all the way down to minus 2. So this one is not going to be the preferred structure. Now, B is preferred due to the electronegativities. So we've said here that electronegativity values are largely ignored, but in this case, B is preferred due to the difference in electronegativities being more than the nitrogen. Moving on to the next one. This looked a little bit nasty, but actually it's not too bad if you break it down and construct it. Ozone in the atmosphere can be formed from the combustion of methane. So it's telling you methane is combusted to form ozone. So that all the information is given to you. So we've got methane, we've got oxygen for combustion. Whenever we have combustion, we produce carbon dioxide and water, and it's telling us that we're also producing ozone. So this is the equation that you've got as your base. Once you've got that, you then balance it. So I do that by just saying, right, okay, 4 hydrogens here, I'm going to need 4 hydrogens here, so make that up to the 2. Once I've made that up to the 2, then have a look at my oxygens and make it so that my oxygens will balance. Okay, so you've got 2 here, you've got 2 here, and then originally you would have had 3 here, so we pop a 2 there and a 5 there just to make the numbers nice and neat and tidy. Okay. Don't do this. Oh yeah, don't do this. Don't write outside the box. If you do that, you are penalised in the exam.